So today we're going to be focusing on multiplying and dividing exponents. I'll show you guys a couple of different examples. Make sure you guys are writing this in your composition book or notebooks, and then at the end, please write down any questions that you have. So on the screen, you'll see the first basic rule for multiplying exponents. For any non-zero value of b and any integer values of m and n, you basically add them. What that is saying is, for example, if you have x squared, that's the exponential form. To expand that would be x times x. However, what we know is that if we have two of the same bases, x squared times x to the third, we can actually rewrite it as x times x times x times x times x. We can actually rewrite the base as x, and then we are being multiplied 5 times. So the rule is basically saying that if you have the same bases with integers in your exponents, you add them. Another example of that would be v to the second times v to the fifth would be saying same base, v to the seventh. If you're not too sure about it, you can definitely expand it out, but it is because we are multiplying that allows us to have this rule. Now, the same rule doesn't apply for adding and subtracting exponents. If you're adding and subtracting exponents, that's a different rule. It deals with similar terms, with coefficients. But today we're just going to be focusing on multiplying and dividing exponents. Okay. So here are some examples that I have. I have 2 squared times 2 to the fifth. Well, there's 2 squared. There's 2 to the fifth. My final solution is 2 to the seventh. This one, the next one, 2a to the third times 3a to the eighth. Now, the same rules apply here. You're multiplying your coefficient first, so 2 times 3 would be 6. And then a to the third, and then times a to the eighth would be a to the 11th. Notice how that in this example, I can only expand the exponents. I'm not expanding 2 times 2 times 2. That doesn't work. Times 3 times a, 8 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And what I have left is 6 and then a to the 11th. The next one, I have b to the 6th times b to the negative 4th. We'll get into negative exponents in the next section, but b to the 6th times b to the 4th, they are the same basis, so they're both integers, 6 and negative 4, so I'm going to add them, and b to the second power. Okay, and that's when you're multiplying exponents with the same base. Next, we have something called the power properties of exponents. We call it kind of like the re-raising. Okay, you have bm, b to the nth power, that whole thing to the nth power. You would multiply the two. So an example of this would be, this is saying x squared to the third power. I'm going to expand that, x squared, that's only 1, multiply by itself 3 times. And then from there, if we wanted to, we can go back to the previous rule I just showed you and expand each of these. And I get 1, 2, 3, 4, 5, 6. That is equal x to the 6. But the shortcut is, if you notice that you have an exponent and then another exponent on the outside of parentheses, you just multiply the two together. 2 plus 2 plus 2 is 6, or you can do 2 times 3 is 6. Okay, either way would work. Same thing with this one. This one deals with the second rule right here. If you have 2, which is my coefficient of 2, w to the third power times raised to the fourth power, you can write it out 4 times. There's one group. There's 2 groups. There's 3 groups. And there's the fourth group. And just like we did before, I would multiply my coefficients. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And then if you really wanted to, you can write out each w 3 times here and here and here and here. Or, since I'm multiplying my w's with the same basis, I just add them. 3 plus 3 is 6. 9, 12. W is being multiplied 12 times. But the rule says that if you know that, you're multiplying here technically speaking, you can break it up. You can go 2 to the 4th power times w to the 3rd power 4 times. Well, 2 to the 4th power is 16. W to the 3rd raised to the 4th power would be, you multiply those together, and you get w to the 12th. Either way works. Okay, so a little bit more expanded from this, but the shortcut would be you would apply the exponents to the number first, and then you would multiply your integers in the second part. Third example is going to be dividing exponents for any non-zero of a value of b and integers for your exponents. If they're the same basis, you subtract. It kind of makes sense. It's the opposite of multiplying. So for example, if I have x to the 4th over x to the 2nd, I'm going to expand both in my numerator and my denominator. Now we just write a whole bunch of x's being multiplied, but don't forget that each of these have a coefficient of 1. So 1x over 1x is just 1. 1x over 1x is also 1. So all I have left is x times x, which is equal to x squared over 1, or we just said x squared. And that's how you would divide exponents with the same base using the expanded form. But because we know that our values have the same base here, I'm just going to go 7b times b times b times b over same thing. There's a 1 here, so 7 divided by 1 is 7. These are gone, so all I have left is b to the 4th. But really what's happening here, when we cancel all those out, because they're the same basis, I get 7b to the 6 minus 4. Because they're the same basis, and you get, oops, sorry, I didn't finish my b's there. So it will be 2. So 6 minus 4 equals 7b to the 2nd. Okay. That's what you're dividing. If they are the same base, you would subtract. Here are 3 examples that I would like you to try with the division property of exponents. Go ahead and pause the video right here. Write these 3 examples down in your notebook. Go ahead and work them out. And then when you're ready, push play and then check your answer with mine. I will go ahead and continue on. I'll start with 6x to the 9th divided by 5x to the 4th. Okay. All right, here we go. So we have 6x to the 9th divided by 5x to the 4th. The first thing I'm going to do is take care of my coefficient. Okay. 6 divided by 5 is 1.2. Next, I have x to the 9th divided by x to the 4th. I know that they're both the same basis of x. Yes, you can write out x to the 9th at the top and then x to the 4th on the bottom, and then start canceling out. All you have left is x to the 5th over 1. But really, we don't have to write this 1. Our final solution would be just x to the 5th. B, I have 3x squared times 8x to the 4th. If I wanted to, I can expand this out like usual, but I'm just going to go ahead and take care of my coefficients. First, I have 3 times 8. That's 24. X to the 3rd times x to the 4th. Same basis. I'm just going to add them. X to the 7th. Divided by negative 4x to the 3rd. Take care of my coefficients. That's negative 6. Zoom in a little bit. And then x to the 7th up top, x to the 3rd on the bottom. All I have left is x to the 4th after I cancel everything out. And again, technically there's a 1 there, but I'm not going to write it. So my final solution is negative 6x to the 4th. Okay. Lastly, we have scientific notation. We'll get more into scientific notation in this section as well. But first thing I'm going to do, take care of my significant numbers there. 7.5 divided by 1.5 is 5. And then here I have x to the 8th times x to the 3rd. That becomes, 10 to the 8th divided by 10 to the 3rd. That would be 10 to the 5th because these are the same bases. So that's my final solution. Okay. So in review, I went over 3 things today. First, we went over multiplying exponents. Multiplying exponents, if they are the same basis, for example, x to the third times x to the second, you just add their integer exponents, x to the fifth. You can always expand it out, but that multiplication symbol right there tells you that you're going to be multiplying them together, therefore the same base, you just add them. Okay. If you have a constant, you take care of your constants first, your coefficients, excuse me, 2 times 2 is 4, and then you follow with the exponents. Next we have the power property, which means if I have v to the third squared, that is the same thing as v to the third times v to the third, which is equal to v to the 6. However, if I wanted to, I can go v to the third times 2, because of this relationship becomes v to the 6. A common mistake is I have something like this, v to 2u to the second squared, is I might forget to do something with the 2, but really when in doubt, write it out. You get 2 squared is 4. W squared squared would be w to the 4th. Because what's happening here is 2 squared times u squared squared. Okay, so you have to take care of your coefficients as well. And then lastly, we have the dividing property. Which means if I have b to the third, excuse me, b to the 4th divided by b to the 2nd, same basis, all I have to do is subtract my exponents, b squared. Okay, so that's all I have for today. Make sure you guys rewatch it. If you have more questions, write down your questions in your notebook, and then we'll go over it in class.